Hello everyone, welcome back to my channel. Today I'll be walking you through Practicum 11 where we use Python and the SymPy library to solve a mathematical problem involving the inverse Laplace transform. We start with the communication system model. The transfer function in the Laplace domain is given as f of s is equal to 1 by s square plus 25. Our goal is to find the time domain signal f of t using the inverse Laplace transform. Now let's look at the code. So here's what's happening step by step. First, we import SymPy. SymPy is a Python library for symbolic mathematics. It allows us to perform algebra, calculus, and transforms directly in code. Then we declare t and s as symbolic variables. S represent the Laplace domain and t represent the time domain. Then we set f of s is equal to 1 by s square plus 25. Then using sp.inverse Laplace transform, we convert f of s back into the time domain. Then SymPy often includes the heavy side step function to represent causality. We replace it with 1 to make the output cleaner. Then finally, we display the simplified time domain signal. The output gives us f of t is equal to 1 by phi sine into phi t. This is the time domain representation of a system's response. It shows that the system behaves like a sine wave with frequency 5 radians per second, scaled by a factor of 5 seconds. So in this practicum, we successfully used Python SymPy to compute the inverse Laplace transform and obtain the time domain signal. This demonstrates how symbolic computation can simplify complex mathematical problems and make them executable in code. If you found this explanation helpful, don't forget to like, share, and subscribe. Thank you.